We reviewing one of the questions from the enums lab yesterday. It was question 3. Question asked, you are given a coin enumeration which describes different coin values. Write a function called get total value from some array that takes in an array of tuple values. So the tuples, there's two values. There's an int and there's a coin enum. Right, so yesterday we saw that indeed, I think Luber or Yulia was asking, can a function take an enum? Yes, it can. We see that example here. Right, so we have a tuple. The first value is an int, second value is a coin, and it returns the total value of all coins in cents. There's a bit there happening. So we need to digest, like, what is the question really asking, right? The question basically is asking, use an enum with passed in values, figure out what type of coin it is. Based on the coin, you need to also figure out how many of that particular coin you have. Everybody with me? So if my first enum says it is a penny, right? We know it's a penny, that's good. But there's 10 pennies. How do we know how many cents we have? We have to look at the penny's raw value. What is the raw value for a penny? 1. So how many cents do we have? 10. Move on to nickel, right? We have 50 nickels. How many cents we have from 50 nickels? We have 15 cents from 50 nickels. 75, right? Shahid, right? So be careful there. The amount of nickels we have is 15, right? So that's not the answer in 15, right? We have to see how many points we have of nickels and go ahead and find out the raw value and multiply it. That becomes the how many cents we have. Everybody with me? So really digest the questions, right? That's a good question to really get us thinking of how to solve it, right? Same as question 5. I really want us to give it an attempt again before I go ahead and solve it, because at the end of the day, we become better developers by banging our head against the wall, right? Once, twice, then you come back, you're like, oh, I think I got it, right? As opposed to like every day solve the hardest problems, I don't think it's ideal, if that makes sense. So we have to like start breaking down the problems. What is the question asking for? The question is asking, given an array of tuples, see what the tuple has. The tuple has a count of the coin. Everybody with me? It has what type of coin and how many. What's the count of it? How many quarters do I have? How many pennies do I have? How many dimes do I have? Right? If I pass in 3 quarters, how many cents do I have? 75, right? We all see that? So we have to do extra work in our calculation to come up with the result. If we do it by hand, we can, right? So 10 times 1, we have 10 there. Right? 75. We have 20 cents, we have 30, and we have 175 here, right? So we add all that together, it should come up to 385. Everybody with me? Everybody with me? But with our programming chops and what we've seen so far with functions, with variables, with multiplying, with adding, with keeping account of stuff, there's a lot of variables there we need, well, no pun, variables there. There's a lot of things we need to be doing in that problem to solve it. We need some sort of running count. How each time you go through a switch statement, you have to keep tally of the total amount of cents. Everybody with me? The first time I come in, what's my first case in my switch statement? I see a penny, right? What's my total count after leaving penny? 10 cents, right? When I move on to nickel, what is my total cents? What is it? You have to add it together.
Oh, sorry.
Right? So 85, right? And then you keep adding it here until you get to the end. So every time you go in a switch statement, you have to make sure you're saying, keep adding to the current value. Everybody with me? So those are like different variables we have to do there. We'll solve it together, but please go back and solve it by yourself. Right? Go away from the solution we come up with and go back and solve it by yourself. Because those are one of the problems. That could be a valid question. Right? We can't say like we've never seen that before. It's like taking everything we've learned right? When you're a carpenter or a baker, right, they give you a recipe to do. You don't say, oh, I've never baked that type of cake before. You take everything you know, the ingredients, and you make a cake, right? Hopefully you don't add more salt than sugar. Things like that, right? So you have to take everything you know to the table to solve the problem. At the end of the day, when you go to your interview, you might have seen the problem before, right? In that case, you go ahead, you solve it. But there might be a problem where you've never seen before. So you have to take what you know to apply to that particular problem. At the end of the day, you might not get the exact solution, but you show the interviewer like, hey, I know how to write a function. I know what type of input my function is taking. I know what type of output my function is taking. I know what a good runtime looks like. So you put all those together, you solve the problem, right? You go walk through your process. I am doing this. I am doing that. I'm writing a function. The function takes in an array. It returns an array, or it returns a Boolean, right? So those are the things we have to start delving into when we solve problems. What is the problem asking for? As we did in reading comprehension, we saw a problem or we saw some comprehension. We read the essay. We took notes, right, everybody? We took notes on what we read, whatever book we read, we took notes on it. We highlighted things, and we went back to solve the problem. Same thing you need to do with code. I see a problem. It's like bigger than I could start thinking about. Break it down. What is the first thing asking? Write a function, right? Right. Write a function. The function takes in an array, right? I need a switch statement. Write those steps down and start breaking it down step by step. Even if you have to go by hand and see how that adds up to 385 here, that's valid. You know exactly what you need to do as far as like writing the steps down. Step one, if I go to a switch and I see a penny, I need to find out the raw value of penny. I look up here, I see the raw value of penny is 1. I need to multiply 10 by 1. 10 is the count, how many pennies I have. I go down to nickel, I see 15. I need to see the raw value of that nickel. It's 5, so I multiply 15 by 5. I add as I go. I need to keep adding. Right? So you could write all those things down. That's where we really start to appreciate problem solving. Right? Break the problem down in small chunks. In chunks we really understand. And we come up with a solution. You might need some help along the way, which is fine, but not helping for the entire problem, right? You might be stuck in some place like, oh, I'm not able to keep count, like my count is changing. Then we'll be like, okay, you're not doing plus equal. You overriding your variable. So little things like that, cool? All right, so let's start solving this problem. So we have the enum, that's great. The enum was given to us here. It's called coin. It has a raw value. This is not associate value, right, everybody? Right? So this is a raw value. So far, so good. It says write a function called get total value. I will just copy the function name. Copy the function name. Command C, copy the function name. So let's go ahead and write the function. It says write the function here. I will start my function with a func keyword. The function name is called get total value. The external argument is called from. Everybody? I could give it an internal. I could call it tuples. It's an array of tuples here. In that array, I have, what's my first value on my tuple? An int, very good. And my second value, my data type, a coin, very good. What does it return? What type of data type it returns? It says returns the value, returns the total value of all coins in cents. So what data type is that? It's an integer, right? Thank you, Chelsea. So here we will have a return type of integer. At this point, we have our function signature. Our function is called get total value. We have an external name called from. Again, you could keep from here. It's just going to be weird to read when you write in your function body, right? So give your function an internal name, tuples. That's fine. And here we have our array of tuples. First value is an int. Second one is a coin. And we return an integer. Great. Next step. So we have an array. The minute we have an array and we want to inspect elements in the array, what do? How do we inspect individual values, individual elements in an array? Map is one way, but what did we learn before map? For loop, right? So we have a for loop here, and map actually, you would have to map it, and then you'd have to do some extra work in the closure. It will get a bit messy for us to read currently. So let's just keep it simple. So here we have for, I'll say for tuple, which makes sense, for one item in my collection of tuples. Everybody with me? Right? For one single tuple in tuples. So that tuple here, if I option click on it, right, it's one single tuple of an int and a coin. Everybody with me? So far, so good. Great. Now, I want to be able to inspect my coin. My coin is an enum. Everybody sees that? My coin is an enum, is that correct? Is that correct?
Yes.
I have my coin type here. It was given to me. It's a coin. It's an enum, right? How do we inspect an enum? How do we go through the cases of an enum? Not in the front, somebody else. How do we go through the cases of an enum? Lilia. How do we go through the cases of an enum? Switch statement, yes. So we'll use a switch statement as Lilia says. So we're going to switch, but what are we switching on? Coins, right? We have to, but how do we get access to coin? Self. In that case, what is self? We can't use self here because self wasn't, the instance did not invoke get to values. Get to the values. Yes?
I think it's the same thing that
Coin that penny. But we have no coin right now, right? Right? So Mr. Eddie is saying we could say tuple dot one. Look at that. We have a tuple, guys. We agreed. Right? Let's go back. We have our element here. It's a tuple, right? It has two values. Everybody agree? How do we access values in a tuple? Dot, right? With dot syntax, right? So if we have three values in a tuple, how do I access the last value in a tuple with three values? What is the last value? 2, right? In that case, we after coin, right? So if you're not sure, you could start typing tuple, type in dot, and you'll see the values, 0, 1. There's only 2 values here. Are we interested in switching on the int? No, we're not, right? We want to switch on the enum. Everybody with me? In that case, our enum is a coin. So I want to switch on my enum. So go ahead and tuple that one. Great. So now I could switch on my enum. Everybody with me? Now we're comfortable with cases. We could say case, penny. We'll come back and fill out the logic. But let's for now just go through all the cases. Case, nickel. Why is it tuple.1? Thank you. So tuple.1, let's go back here. Tuple.1, are we interested in switching on the integer? No. Are we interested in switching on the coin? One is the second thing in the tuple. Exactly. So our tuple has an integer, and our tuple has a coin. If it was reversed, if the coin was first, it would be dot 0. You with me?
Yeah.
And
you can go through it, sorry, you can go through a tuple the same as the erase, but that.
yes, but be careful when you say go through, not iterate through, but access.
No, like
Yeah, access. But not with the subscript, with dot. Cool? Because with the array, you say subscript 0.
Yeah. Okay.
All right? Cool.
How did you make the options?
How did I make the options come up? Okay, so if we go back, take out that 1, right? And just type in dot, then the options come up before doing anything else. You just simply type in dot. Cool? It did not come up for you. Are you saying for tuple in tuples here? Cool? How are we doing? We good? Okay, so dot one here. Great, great, great. Let me see if I could actually do something else here. So I could say count. Let me see if this is going to work here. One second, we're going to come back to that. Okay, yeah, that should work as well. So what we did, let me show you what I did here. Let me go back to make it easier to read. We have our dot one, right, everybody? Everybody? You could make your function internally easier to read by overriding or putting a label on your tuple data type. We did that with associated types yesterday, remember? Right? Associated values yesterday. You could give your data types labels, right? Instead of saying like .0, .1, I could give my integer some sort of name that makes it more meaningful. You with me? Hello, are you with me? So right before our integer here, go back to the function definition, right? Right before our integer, are we following along? Right before my integer, I'll give it a name. You could give it any name you want. A name, for now, makes sense as count or number of points. Right? And for my coin, I'll just simply say coin. You still with me? And now, instead of saying 1, let's delete that and use dot again. And now we have the names that we internalized. Everybody with me? So now I say, instead of saying .1 or .0, which gets a bit confusing, it shows you the type. But now I could say simply what I want to switch on is my coin. Everybody with me? Okay? All right. Cool. So now we have case penny, case nickels. The break part, somebody brought that up. For now, just to get rid of the errors, I'm saying break. I'll come back and finish the code. All right? So case, next we have dime. And lastly, we have quarter. Right? It's still asking for a return. Before we do any logic, let's get rid of our errors. Before we do any logic, let's get rid of our errors. What are we returning? Total number. So let's create a variable called total number of cents. Yes, sir. Yes. Everything with that particular problem should be in the function, right? If you have it outside, it's not the best way to solve that problem. Cool? All right, so here we have total number of cents. So let's return total number of cents. So at this point, we have no error messages. We have the skeleton of our solution. We need to go in and continue the logic. But for now, we return in an integer. We taking in, our input is an array of tuples. We use a for loop here to go through each tuple. Each tuple has a number of coins and the type of coin. Maybe we should change that to type of coin. Let's option click on coin here. Oh, sorry, command click on coin, editing scope, and let's change that to, oh, look at that, it's not gonna work on that one, funny. Just do it manually. Mine did not work. So type of coin is a better name. So type of coin here and type of coin here. Right. So we use this a for loop to iterate through the tuples. Each tuple has number of coins and type of coin. Right? So far, so good. Any questions before we move on? And we agreed each time we come across a case we have to look at its raw value. We agreed with that, right? So we look at the raw value, we multiply the raw value times what? Times what? The raw value is the value of the coin. So we multiply that times, so number of coins, right? According to what Christian is saying, everybody with me? So every time we come to some case here, instead of our break, we'll say raw value times number of coins. Cool? So let's go ahead and do that. And we have to keep tally. Our total number, we have to keep this tallied. Every time we come in here, we have to add to the previous value. Everybody with me? I can't do equal here. Do we agree? It's going to override the value. Right? Everybody with me? So here I want to keep track as I count. So I'm saying plus equal. Shorthand syntax for arithmetic here, for adding. And what am I adding? Let's go ahead and add. Let's first get our coin dot penny dot raw value. Raw value is an integer. We agree? Our enum specified its raw value type of what? What is our enum raw value type, Tiffany? What is the data type of our raw value for the enum? An int, right? An int. That's why when we said raw value before finish typing it out, we see an integer. We see that? Cool. So now we have a valid integer. Everybody with me? Cool. So press enter here, and we're multiplying it, right, by what? How do we get access to the number of coins? Tuple dot number. Very good. Great. But you got it to work the first time, right? Okay. As I said, like if you get it to work, that's fine. That's the point of it. Like get it to work first, and you could optimize it later. Cool. All right. So now let's continue going on. I'm not gonna copy and paste just because I want us to get the use of typing here. So now I will say total number of cents plus equal my coin. And this time it's nickel, right, everybody? Everybody, for nickel? I'm getting the raw value. I'm multiplying it by my tuple times number of coins. Right. Next one I'm going to have is my total number. You could easily write a function for that, but for now, let's just keep everything here. I'll have my coin times my dime times my raw value times my tuple, times number of coins. And lastly, for the quarter, I'll say total number plus equal my coin times my coin dot dime dot quarter, sorry. Get the raw value of the quarter and multiply by what? By tuple dot number of coins. Everybody? Okay, so at the end of all that, we should have the total number of cents here on line 32. And at that point, our function is complete. We return our value to the caller. Let's make sure we're all good here. We have nickel here, we have dime, we have quarter, and we have penny. So far, so good? Can we continue? Yes, sir. Okay.
What is the switch? Is there a reason to be using the switches like specifically with enums?
On our particular case here, we're showing it the long method where we have a switch statement. You could Slack us your solution and we'll take a look at it, right? So Slack us your solution and we'll talk about it. So here we have our tuple. We know we switch on tuples to get the cases. And as we switch on the tuple, we add the value. You with me, Matt?
Yeah.
Right? And at the end, we get our total number of cents here. Right? Okay. Everybody wrote the code. Can we test now? Okay. So let's go down, uncomment our array. You did, where did we declare number of coins? Oh, you got it? Okay, cool. I mean, you could map the thing. You could do so many other things, right? Yeah, yeah, yeah. Exactly, exactly. And if we're learning here. We don't want to complicate it. All right. How we doing? We good? We typed it out. Zara, you good? Okay. So now on comment where it says on comment the lines below. Also on comment the assert. On comment the assert, right? Expected total is 385 here on line 44. The total from our function should be 385, correct? Everybody with me? And our assert says 385 should be equal to 385, right? If it's not, then we'll get an error saying was expecting 385, but got whatever wrong answer you got. So now let's go ahead and run our function or our playgrounds. No, that's fine. And now I have 385. Do we see 385? Right? In our function, we also have 385 here. Do we see that in the preview, in the results pane? So at this point, we have solved the problem, right? Our assert passes, our function returned the correct value, and yes, we could make this more optimized, right? But for the purposes of understanding how to use a switch statement on an enum, we have this case, right? Cool. Any questions so far? All right, I'll slack out what we have here. You could take out the names. You talking about those names here?
Yeah.
You could.
Like, I know that we can keep it, but like, would it look better to have donations and just put like,
That zero is fine. That zero, that one is fine. Yeah, but I'm just showing you guys you could name it.
yeah,
Right?
because it helps.
Exactly. All right. Any other questions? Did we get the code to run, the one I slacked out? And you could also take a look at Matt's solution offline when you're ready. All right, but understand this solution, right? Cool. So that's the end of that particular review.